All right, our very last bit for section 13.1 is going to be creating an exponential regression. So an exponential regression, reading right here, is a statistical method used to fit an exponential model to a set of bivariate data. Bivariate just means two variables. We have two variables, an input and an output. We're going to use a graphing calculator right now, but I will in later videos show you how to do it using Desmos to find that exponential regression. So we already have the data in our calculator. Okay, so I'm going to go up and I'm pull up my calculator. Actually, let's do it this way so we can do it side by side. Okay, so step one is you have to have your data in your stat button. So stat edit, there is our data for this problem. We're still doing the aquarium problem. So we have our data in list 1, list 2. So step 1, so let's go ahead and put this in our notes. Step 1, we have to input data into the stat button. Stat, then edit. Okay, we could look at our data, which we just did in our last bit, but we're not going to. We know what it looks like. So step 2, okay, we're going to calculate with our data. So that's the stat button. So let's get out of there. Stat button. And then we're going to arrow over to calculate. C-A-L-C. So stat, then calculate. And we now want to do, instead of a linear regression, we want to do an exponential regression. So that's the EXPREG, which I believe in most calculators is option 0, an exponential regression. So in my X list is my list 1. Yep, it's just verifying. If your X is in a list other than list 1, you'll have to change that. My Y list in list 2. Yes. And now I want to go back down to where it says store regression EQ. And I want to automatically put it in my Y1. So to do that, I hit vars, the vars button. Then I have to hit yvars. And then function. So function. And then y1. That's where I want it to go, y1. This is just telling my calculator to put whatever equation I get into y1. And then I hit enter. So there's my equation. Y equals, it tells me a times b to the x. It tells me my A is 250, which we know that. We know our starting value is 250. But for my B, it has me using 1.19. Put that in parentheses to the X. Now, if we go down and look at my R value, remember that R and the R to the second, again, that R to the second is just the square of the R value. These are what we call the correlation coefficient. The closer to 1, the better the fit. Meaning, the closer it is to actually fitting the data. So now if we go and look at the graph, there is my equation. So there's my data point. So if I go and I hit the trace button, there I'm tracing and I arrow over. Right now I'm tracing on my points. I'm tracing on my plots. I have to hit the down arrow to now trace on the graph itself. But I can now use this to make predictions. What do I think how many visitors are going to come to the aquarium in the year 2020, which would be inputting a 10? Approximately 1,477,000. So that's got 3 more zeros behind it. So I can now use this equation to make predictions. So my equation is this guy right here. Y equals. But it's important to note your calculator always gives it in terms of Y and X. This equation, the table, is in V and T. T is my input, so I need to rewrite it. So it would be V equals 250 times 1.19 to the T. There's my equation that fits this data set.